Preparing for a solutions architect at Confluent interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you explain Apache Kafka and Confluent to a business stakeholder? I would describe Kafka as a durable, scalable nervous system for moving business events in real time. Instead of repeatedly polling databases, applications publish events that many consumers can use independently. Confluent builds on Kafka with cloud-managed clusters, connectors, governance, stream processing, and operational tooling. For a business stakeholder, I would emphasize faster decisions, reduced integration complexity, and reliable data availability rather than partitions or brokers. I would then connect those outcomes to their highest priority use case. While answering, focus on Kafka as an event streaming platform, real-time data movement, business outcomes, Confluent's managed and enterprise capabilities, and adapting technical depth to the stakeholder's role. Question 2. How would you discover a customer's requirements before proposing a Confluent architecture? I start with the business problem, not a product pitch. I ask what decision or process must improve, who consumes the data, and how success will be measured. Then I map sources, transformations, consumers, volumes, latency targets, retention, availability, security, compliance, and operational ownership. I also identify constraints such as cloud strategy and migration timelines. Finally, I validate assumptions in a written architecture and prioritize a small proof of value before recommending a broader rollout. Make sure to cover business objectives, current architecture, event sources and consumers, latency and throughput, availability, security, compliance, operational ownership, budget, and measurable success criteria. Question 3. Design a Confluent architecture for real-time fraud detection. I would publish payment, customer, device, and account events into separate governed topics, using Avro or protobuf schemas. Stream processing would join transactions with reference data and recent behavioral state, producing scored alerts for investigators or automated controls. I would partition by an appropriate customer or account key, replicate across availability zones, and secure sensitive fields through encryption and access controls. I would monitor end-to-end latency, consumer lag, false positives, and processing failures, then tune the design using production-like traffic. In your answer, discuss event producers, topic design, schema management, stream processing, stateful enrichment, alert consumers, exactly once considerations, resilience, security, and measurable fraud detection latency. Question 4. What is the difference between Kafka topics, partitions, brokers, and consumer groups? A topic is a logical stream of records, while partitions divide that stream into ordered, append-only segments. Brokers store and serve partitions, including replicated copies for resilience. A consumer group is a set of consumers that jointly process a topic, with each partition assigned to one consumer within that group. This enables parallelism, but ordering is guaranteed only within a partition. Therefore, partition key selection and consumer capacity directly affect scalability, ordering, and processing balance. Be sure to define each component clearly, explain partition-based parallelism and ordering, describe broker storage and replication, and show how consumer groups distribute work. Question 5. How would you choose Kafka partition keys for a customer's workload? I choose a key based first on the business ordering requirement. If all events for an account must remain ordered, account ID is usually appropriate. I then test cardinality and distribution to avoid hot partitions, because one heavily active key can limit throughput despite many partitions. I consider consumer lookup patterns and future growth as well. If requirements change, rekeying is not trivial. It can alter ordering and requires a controlled migration, dual publishing, or downstream reconciliation. Focus on required ordering, access patterns, cardinality, distribution, hot partitions, future scalability, null keys, rekeying implications, and the relationship between partitioning and consumer parallelism. Question 6. How would you troubleshoot increasing consumer lag in Kafka? I would first establish whether lag is isolated to certain partitions or growing across the group. Then I would compare producer rate with consumer processing rate, inspect consumer CPU, memory, network, poll behavior, rebalances, errors, and downstream latency. Partition skew may indicate a poor key, while slow database calls may limit throughput. I would scale consumers only if partition capacity exists, then validate recovery and determine the root cause so the issue does not recur. Mention defining lag, checking producer throughput and consumer health, examining rebalances, processing latency, partition skew, downstream dependencies, resource metrics, and using controlled remediation rather than immediately adding consumers. Question 7. When would you recommend Kafka Connect instead of building a custom integration? I recommend Kafka Connect when the integration follows a common source or sync pattern and a mature connector already exists. It provides standardized configuration, scaling, offset management, monitoring, and operational consistency without maintaining bespoke plumbing. I would verify support for authentication, schema behavior, deletes, retries, and data types. Custom code becomes appropriate when business logic is highly specialized, the connector lacks essential capabilities, or the integration requires orchestration beyond Connect's scope. I would still isolate and monitor that code carefully. Discuss standard source and sync patterns, connector maturity, configuration versus custom logic, operational benefits, transformations, error handling, unsupported requirements, and when custom development is justified. Question 8. How would you explain Schema Registry and Schema Evolution to a customer? Schema Registry centralizes and versions the contracts that describe event data, commonly using Avro, JSON schema, or protobuf. It prevents producers and consumers from silently disagreeing about fields or data types. I would select a compatibility policy based on deployment patterns, usually backward or full compatibility for independently released services. Adding optional fields is generally safer than renaming or changing types. I would enforce compatibility in C/CD, document ownership, and treat schema changes as managed API changes. Cover the purpose of schemas, compatibility modes, producer and consumer contracts, backward compatibility, field additions and removals, serialization formats, governance, and deployment controls. Question 9. How would you design for high availability and disaster recovery with Confluent Cloud? I begin with explicit recovery point and recovery time objectives. Within a region, I use sufficient replication and availability zone distribution, appropriate acknowledgements, and resilient client settings. For regional recovery, I evaluate active-passive or active-active designs, using cross-cluster replication where the business requires continued access to data. I define failover ownership, DNS or application routing, offset and duplicate handling, and run regular recovery exercises. The final design balances resilience, latency, operational complexity, and cost rather than assuming maximum redundancy is always justified. In your answer, address availability zones, replication, recovery point and time objectives, cross-region architecture, failover, data replication, client behavior, testing, and the trade-off between resilience and cost. Question 10. How would you secure a Confluent environment containing sensitive customer data? I would apply defense in depth. Users and applications receive strong identities and least privilege permissions on clusters, topics, consumer groups, and schemas. Data is encrypted in transit and at rest, while private connectivity reduces exposure. Sensitive fields may require tokenization, masking, or encryption before publication. I would separate environments, store credentials in a secrets manager, enable audit visibility, and define retention policies. Finally, I would test access paths and review permissions periodically against regulatory and internal control requirements. Mention identity, least privilege authorization, encryption, private networking, secrets management, field-level protection, audit logs, environment separation, compliance requirements, and periodic access reviews. Question 11. What is the difference between at most once, at least once, and exactly once processing? At most once processing may lose records but avoids duplicates. At least once processing retries failures, so records are not normally lost, but duplicates can occur. Exactly once processing coordinates consumption and production transactionally within supported boundaries, reducing duplicate effects. I would not promise it universally without understanding external systems, because database writes or APIs may still require idempotency. I choose the guarantee based on business consequences. Financial postings may need strong controls, while telemetry may tolerate occasional loss or duplication. Be sure to define delivery guarantees, explain duplicates and data loss, discuss idempotent producers and transactions, identify practical limitations, and connect the guarantee to business impact. Question 12. How would you approach migrating a customer from point-to-point integrations to event streaming? I would inventory integrations, dependencies, data ownership, failure points, and service level requirements before designing the target event model. I would start with a high-value, bounded domain and establish naming, schemas, security, and operating standards. During coexistence, change data capture or controlled dual publication can keep legacy and streaming paths aligned. I would onboard consumers incrementally, reconcile outputs, monitor business metrics, and retire point-to-point links only after proving reliability. Migration success requires organizational ownership, not just deploying a cluster. Discuss current state assessment, target event model, migration sequencing, coexistence, CDC, dual rights or publication, consumer onboarding, reconciliation, decommissioning, ownership, and change management risks. Question 13. How would you estimate capacity and cost for a Confluent deployment? I would gather average and peak records per second, event size, retention, replication needs, consumer count, processing requirements, and expected growth. I would distinguish ingress, egress, storage, and stream processing costs, because fan-out can materially increase consumption. Partition count must support parallelism without creating unnecessary overhead. I would model normal and burst scenarios, include network and connector costs, and validate assumptions with load tests. Then I would present cost drivers and optimization levers transparently to the customer. Cover event size, message rate, peak traffic, partitions, retention, replication, ingress and egress, consumer fan-out, processing, storage, growth, and validation through load testing. Question 14. How would you use ksqlDB or stream processing in a customer solution? I would use ksqlDB when the customer needs continuously updated transformations, filters, aggregations, joins, or materialized views, and the team benefits from SQL rather than application code. Stateless operations are straightforward, while stateful joins and windows require careful keys, retention, and out-of-order event handling. I would validate semantics and performance with realistic data. For highly custom algorithms, complex orchestration, or an existing Spark-based platform, I might recommend another framework while keeping Kafka as the event backbone. Explain when continuous SQL is appropriate, stateless versus stateful processing, joins and windows, materialized views, key requirements, state management, testing, and when another processing framework is preferable. Question 15. A customer says Kafka is unreliable because records appear out of order. How would you respond? I would first clarify what they mean by out of order: arrival time, event time, processing completion, or business sequence. Kafka guarantees ordering within a partition, not across partitions. I would verify that related records use the same key, inspect producer retries and acknowledgements, and check whether parallel consumers or downstream processing are changing observed order. If events arrive late, event time handling may be needed. I would reproduce the issue with offsets and timestamps before proposing a configuration change. Focus on ordering guarantees within partitions, key consistency, retries, multiple consumers, timestamps versus arrival order, producer configuration, and diagnosing the customer's specific observation. Question 16. How would you run a successful proof of concept for Confluent? A strong POC tests a business hypothesis, not merely whether messages can be published. I would define measurable outcomes such as latency, throughput, recovery time, or reduced integration effort, then select a representative workflow and realistic data volumes. The POC should include security, schemas, monitoring, failure handling, and the customer's operating model. I would document assumptions, test limits, and lessons learned. Before starting, I would agree on production exit criteria and the decisions the POC must enable. Mention a clearly scoped business hypothesis, success metrics, representative data, production-like constraints, architecture decisions, security, observability, stakeholder alignment, and a path from POC to production. Question 17. Tell me about a time you disagreed with a customer or sales teammate on an architecture. In one engagement, a stakeholder wanted a single shared topic to minimize setup, while I believed domain-specific topics would improve ownership and access control. I first acknowledged the cost concern, then modeled expected consumers, retention, permissions, and failure isolation. We tested both approaches with a small workload and reviewed the results together. We chose separate topics with reusable standards, keeping operational effort manageable. The customer gained clearer governance, and the team avoided a later redesign when additional consumers were introduced. In your answer, use a concise star structure, show listening and commercial awareness, explain the technical trade-off, use evidence, demonstrate collaboration, and finish with the measurable outcome. Question 18. How do you explain a complex technical architecture during an executive presentation? I begin with the executive problem and desired outcome, such as reducing data latency or simplifying integrations. I use one simple diagram showing sources, the event platform, consumers, and control points, then quantify expected benefits and key risks. I avoid unexplained product terminology and distinguish decisions from implementation details. If deeper questions arise, I can provide an appendix or technical session. I finish with the recommendation, investment, dependencies, and specific decision needed from the audience. Be sure to cover audience adaptation, business-first framing, a simple visual narrative, major risks and trade-offs, quantified outcomes, decision requests, and reserving technical detail for follow-up. Question 19. What observability would you implement for a production Confluent solution? I would monitor both technical health and business behavior. Core signals include throughput, request latency, broker or cluster utilization, consumer lag, rebalances, under-replicated partitions, connector errors, task restarts, schema failures, and stream processing state or query latency. I would trace records where feasible and expose dead letter volumes. Alerts should be actionable and tied to thresholds or trends, not every transient fluctuation. I would also monitor business outcomes, because a technically healthy pipeline can still deliver incomplete or misleading data. Discuss platform, producer, consumer, connector, and stream processing metrics, lag, throughput, latency, errors, dead letter handling, alert thresholds, business indicators, and incident response ownership. Question 20. Why do you want to be a solutions architect at Confluent? I am drawn to Confluent because event streaming solves a fundamental problem, making trusted, timely data available across an organization. My background combines architecture, customer discovery, and hands-on troubleshooting, so I enjoy translating business priorities into practical designs and guiding teams through adoption. Confluent's broader platform, including managed Kafka, connectors, governance, and stream processing, creates room to solve complete customer problems rather than isolated integration tasks. I would bring technical credibility, curiosity, and strong stakeholder communication to every engagement. Make sure to connect your technical experience to event streaming, customer impact, consultative selling, architecture leadership, Confluent's platform, continuous learning, and a specific motivation for the role. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.